Hello everyone. In this video we will learn the exponential and logarithmic functions. And if we are talking about an exponential function y equal a to the power of x, in which a is a number greater than 0 and a cannot be equal to 1, we call the a base and x is my exponent. Now, if I want to sketch the graph of a basic exponential function, it will look like something like that. Here we go. In which this point here is going to be my 0, 1, which is the y-intercept. And the x-axis, y equals 0, is going to be a horizontal asymptote. The domain is going to be all real numbers, and the range will be from 0 to infinity, open at 0. 0 is not included. Now, if I try to take the inverse of this function, so the inverse will be symmetry over y equal x. We've done the inverse before. And I try to reflect y equal a to the power of x over y equal x, I'm going to get this function here. Well, this function, in this case, the y-axis, which is x equals 0, will be my vertical asymptote. And this point will be a reflection of this, so this is going to be 1, 0. We call this function a logarithmic function. The domain will be the range of a to the power of x, so the range was 0 to 1. Then the domain for this function is going to be 0 to 1, to infinity, sorry. So here the range was 0 to infinity. The domain will be here 0 to infinity. The domain of the exponential function was all real numbers. Now the range will be all real numbers here. Okay, so it's going to kind of switch between domain and range. Now, so if I have y equal a to the power of x, the logarithmic function will be log. The base comes here, and the answer here, this one will be here, and x will be the answer of my logarithmic equation. So how do we read it? We will read it y equal log x to the base of a. So a is going to be my base. Y in this case is going to be my exponent, as you can see here. Now, here we need to change from the exponential statement to the equivalent logarithmic statement, okay? So if I have 3 to the power of 2 equal to 9, we know that 3 to the power of 2 equal to 9. As a logarithm, how we are going to write it? We will write logarithm of 9, that's the base, right? To the base of 3 will be equal to the exponent. That's how you rewrite it. One more time. In this case will be the logarithm of 8. The base is going to be base, so the base, we write it here, equal the exponent. Now, what about if the base is 10? Well, if I want to write it, I'm going to write log, okay, 1000 to the base of 10 equal 3. But we don't write the base of 10. So when there's nothing written here, that means it's a base of 10. Okay, so one more time. A log of a base of 10 is known as a common log. It's a common log, and no need to include the base. So once you see log x, that means right away you can tell the base is 10. Okay, so whenever you have log x and the base is not there, that's a base of 10. So one more time, how do we write it as a logarithm? So it's going to be log 100 to the base of 10, but we don't write it, equal 2. Okay, now what about e to the power of x equal 8? Well, first we need to know what is e. E is actually a mathematical constant approximately equal to 2.71. Now also the e is the base of the natural logarithm. So what is a natural logarithm? It's something we don't use log, but instead we use len. So len is a natural logarithm to the base of e. So if I want to write this as a logarithm, usually we should do this, log 8 to the base of e equal x, right? But we don't do that when it comes to the base of e. We say len 8 equal x. Now here we could say len y equal 2.2. So by default, if it is len, it means the base is e. Okay? Now, what about if I want to change between the logarithm statement to an exponential statement? So, for example, in this case, I could say 8 equal the base is 2 to the power of 3. So remember, this is the exponent and this is my base. Okay, here it will be 3 equal a base is a to the power of 6. Now this one, well, what is the base? Base is 10, but we don't write it. So we can say 10 to the power of 2 equal 100, and it makes sense. 10 to the power of 2 is 100. And for example here, 2 to the power of 3 is 8. Now what about here? Again, the base is 10, so I could say 10 to the power of x equal 10,000. Okay, now what about if I have len 4? Then we know that the base was e, right? So I could say e to the power of x equal 4. That's my exponent, remember. Here, again, e. So e to the power of 5 equal x. Okay, so here we need to learn some properties of logarithm. We're going to start it with the first property when the number here is 1, logarithm of 1. Let's say, for example, I want to find the logarithm of 1 to the base of anything, 5. The answer will be 0, and you can try it by using your calculator. Also, a logarithm of 1 to the base of 1,000 will be 0. Any log, the base of 1, it does not matter what is the base, the answer will be 0, including len 1 is 0. So len 1 is 0. Log 1 to the base of 10 equal to 0, and all of these. So log 1 is 0. Okay, that's the first important property. Then, what about if these are equal? So for example, log 5 to the base of 5, or len e, the base is e, or log 10, the base is 10, or log like let's say 59 to the base of 59. All of these are equal to 1. Okay, so that's my second property. Next, if I have a log a to the power of x to the base of a equal x, so what is exactly happening here? I have, this is a base, right? And this is another base, so I have two bases. These can cross out each other, and that's x. Now there's a reason behind that. Let me give you this example. If I have a log of 5 to the power 3 to the base of 5, okay? So what happened? First of all, I can take this 3 and send it out. That's basically this rule here. This is exactly what this rule is saying. So that's going to be 3 log 5 to the base of 5. Now we have done this here. This is basically equal to 1, right? So 3 multiply 1 is equal to 3. So by default, if I have log 5 to the power of 3 to the base of 5, the answer right away can be 3, and it's kind of crossing out all of this. One more example. If I have log 9 to the power of 4 to the base of 9, the answer right away will be 4. And let me just go through this rule again, because this is very, very important rule. If I have a logarithm of, let's say, 5 to the power of 2 to the base of anything, 3, I can easily take this 2 and send it out. So that's going to be 2 log 5 to the base of 3. Okay, so the power here can be taken out behind the logarithm. And again, anything related to logarithm, it also includes the natural logarithm, which is len. So I could use len for the same thing. So I could say len e to the power of 4 equal 4, okay? Because the base is e, right? And this is going to cross out. Now what about this rule here? Okay, let me give you the rule by using an example. If I have a logarithm of a third root of x to the base of 5. Okay, so no, let me say, for example, 5. We know that a square root of 5 is basically 5 to the power of 1/2. And a third root of 5 is basically 5 to the power of 1/3. We know all of these things, right, from the exponential rules. And that means I could rewrite this as log 5 to the power of 1/3. And this is 5. Now, I can easily take 1/3 and send it out. So that's going to be 1/3 log 5 to the base of 5. And we know that this is basically equal to what? To 1. So 1/3 times 1 is 1/3. That's exactly explaining this rule. So if I can write this as a power of 1 over b, and I can take 1b out, 1 over b out. Next, we know also from the exponential rules that any x to the power of -4 is equal 1 over x4, right? So if I have a log, let's say, of 1 over 5 cubed, and let's say this is 5, okay? How we can simplify that? Okay, well, I could write log 5 to the power of -3 to the base of 5. Then I can take the -3 out. That's going to be -3 log 5 to the base of 5. And since we know that this is going to be 1, so the answer will be -3. So here what happened? 1 over x to the power of n is basically x to the power of -n, and we can move the -n out. And then we can continue simplifying. Okay, now, next. Let's say I have 5 to the power of log, let's say 3 to the base of 5. Now, if I have a base here and a base here are equal, these are bases, right? The answer right away will be 3. Okay. Next, if I have log, let's say 5 to the power of 2, and here I have 5 to the power of 3. So basically, again, this base and this base are equal. So the final answer will be this over this, so 3 over 2. One more example about the same property. So let's say I have logarithm of 3 over 7, and here I have also 3 over 4. So the answer would be 7 over 4. Okay, now here. If I have a fraction, I know that 2 over 3 to the power of 5 is basically equal 3 over 2 to the power of -5. We know that. So how we are going to use this to prove this property? Well, a logarithm, let's say 2 over 3, and I have here 3 over 2 to the power of 5. What we can do, we can change this. So it's going to be log 2 over 3 to the power of negative 5, and this is 2 over 3. Now, based on this rule, I could say negative 5 over, what is the power here? 1. So it's going to be negative 5 over 1, which is equal to negative 5. So I'm trying to apply this rule here. So since the bases are equal, then it's going to be this over this. So this over this. Okay? So one more example for the same one. Let's say I have log 4 over 7, and here 7 over 4 to the power of 2. So I could easily say it's log 4 over 7 to the power of negative 2, and that's 4 over 7 to the power of 1. And since I have the same bases, so it's going to be negative 2 over 1, that's negative 2. Okay, now there is a rule related to the multiplication. So for example, if I have a logarithm of 4x to the base of 2, since there's a multiplication here, I could split the multiplication and turn it into addition. So it's going to be log 4 to the base of 2 plus log x to the base of 2. Now you can simplify it this more, so it's going to be log 4 is basically 2 to the power of 2, and this is 2 to the power of 1, right? So since I have the same bases, so the answer will be 2 plus log x to the base of 2. That's the simplest form. So one more time, if I have a log of multiplication, I can split the logarithm and put a plus in between them, as long as x and y are greater than 0. Now for the division, the only difference is going to be the negative. So let's say I have log 4 over x to the base of 4. So since I have the 4 over x are divided, so I can split it. 4 and 4 minus log x and the same base 4. Now we know log 4 to the base of 4 is 1 minus log x to the base of 4. Okay. Now, in exponential, we know that if I have a to the power of x equal a to the power of y, that means x equal y. For example, 3 to the power of 2 equal 3 to the power of x. Okay, so if the bases are equal, then I know that x equal 2. X will be equal to 2. That's the way we solve the exponential equations. Now about the logarithm. Now for the logarithm is basically, if I have two logs to the same bases like a and a, then the x will be equal to y. So example for that, let's say logarithm of x to the base of 3 equal logarithm of y to the base of 3, then I know x will be equal to y. Okay guys, now we will learn how to solve exponential equations and logarithmic equations. So in this video, where I'm going to focus only on solving exponential equations. So we'll start with this equation, 2 to the power of 2x minus 1 equal 4. How we are going to solve that? Well, there are two methods of doing this. One simple method is by making both same base and use this rule, a to the power of x equal a to the power of y, then x equal to y. Now, since I have 2 to the power of 2x minus 1 equal, I can write 4 as 2 to the power of 2. Now, since the bases are equal, then the exponents are going to be equal. So 2x minus 1 equal to 2, 2x equal 2 plus 1, 2x equal 3, and x equal 3 over 2. So your set of solution is basically 3 over 2. Remember, you don't write x equal inside the set of solution. Now, what about this question here? So again, 3 to the power of x squared minus 7 equal 27 is basically 3 to the power of 3. And then multiply 2x. So now I have the same base. So x squared minus 7 equal 3 to x. X squared, you can move this all the way to that side. It is 6x. It will be negative 6x minus 7. And now you can factor it. So it's either x equals 7 or x equal negative 1. Okay, so the solution set is negative 1 comma 7. Let's try this question here. So again, I could rewrite everything to the base of 2. So 2 to the power of 2, and x is there, multiply 2 to the power of x squared equal 2 to the power of 4 and multiply 2. Now, so I have a rule in which if I have a to the power of x multiply a to the power of y, then the answer will be a to the power of x plus y. So I can do the same here. Simplifying, it will be 2 to the power of 2x plus x squared, which is equal to 2 to the power of 8. Now, since I have the same base, then 2x plus x squared will be equal to 8. So I can just x squared plus 2x equal 8. X squared plus 2x minus 8 equal to 0. And you can factor it. So it's either x equal negative 4 or x equal 2. So your solution will be negative 4 and 2. Okay, what about if I have e? Well, it's the exact same idea, in which you will treat e as any other numbers. So I do have here e to the power of x squared equal a to the power of 3x, and can rewrite this as a to the power of negative 2. And then same, it will be e to the power of 3x minus 2. I have the same base, then x squared will be equal to 3x minus 2, and you can solve this quadratic equation, which is going to be equal to x minus 2, x minus 1. So x will be 2 or x will be 1. So your solution is 1 comma 2. Now one more question. So I can write it as 2 to the power of 2 and then 2x plus 1 equal 2 to the power of 3 and x plus 1. Now again, since I have the same base, then 2x plus 1 will be equal to 3x plus 1, 4x plus 2 equal 3x plus 3, 4x minus 3x equal 3 minus 2, and x will be equal to 1. So your solution is 1. Now what about if I was unable to rewrite the function as to the same base? In this case, I will be taking len for both sides. And based on the what we have done before, I could move these to that side. So it's going to be 2x plus 1 with a bracket, len 4, x plus 1, len 6. I can expand 2x len 4, so you can expand plus len 4 equal x len 6 plus len 6. Now you can move the constants together and the variables together. Ln 4 minus x ln 6 equal ln 6 minus ln 4. Take x as a common factor. And now you can divide everything by 2 ln 4 minus ln 6. That's a constant. You don't need to use the calculator here, okay? So x will be equal to ln 6 minus ln 4 over 2 ln 4 minus ln 6. Now you can use the calculator, but that's called an exact answer. If you use the calculator, you can round it to the nearest any decimal place. Now what about if I go back to the previous question, the answer was 1. Can I use the logarithm method? Well, let's try. If I take ln for both sides, then that's going to be 2x plus 1 ln 4 equal x plus 1 ln 8. If I expand, I will get this plus ln 8. If you move the variables together, that will be, we can take now x as a common factor, minus ln 8 equal ln 8 minus ln 4. And then you can easily divide both by 2 ln 4 minus ln 8. 2 ln 4 minus ln 8. Your final answer will be ln 8 minus ln 4 over 2 ln 4 minus ln 8. Well, if you put this in the calculator, you will get -1, the same answer we got before. So let's look at this question again. So as we can see, you cannot have the same pace, and you have to use the logarithm method, which you will take ln or log or whatever you want. I prefer to take ln. So it's going to be 1 minus x ln 3 over 5 equal x ln 5. Now we learned that ln x over y will be equal ln x minus ln y. So I can easily make this ln x minus ln y. So 1 minus x ln x minus ln 3 minus ln 5 equal x ln 5. Now you can expand. That's going to be, so I'm going to expand everything. So I'm going to expand the 1 first. Ln 3 minus ln 5 minus x ln 3 plus x ln 5 equal x ln 5. So basically I multiply these and then I multiply these two. Now I'm gonna move this one to the side. Minus x ln 5 equals 0. These two will cross out each other, and I'll keep only this in this side. Equal ln 5 minus ln 3. And then you can divide both sides by negative ln 3. So your x would be equal to ln 5 minus ln 3 over negative ln 3. Now of course you can take this negative up. That's going to be negative ln 5 plus ln 3 over ln 3. Now of course some people might try to simplify it more. Negative ln 5 over ln 3 plus ln 3 over ln 3. That's equal negative ln 5 over ln 3 plus 1. That's called an exact answer. And if you want to find the answer by decimal, then you can use the calculator to calculate this. Now this question here, since I have the same base, then I can take len, or I can, since I have the same base, then the exponents are equal. But I'm going to take the len, okay? I would like to show you this. It's going to be 2x plus 1 len e equal x plus 2 len e. Well, we know this is e and the base is e, so this is 1 and this is 1. So now 2x plus 1 equal x plus 2. So 2x minus x equal 2 minus 1, and x will be equal to 1. So your solution is 1. Last question. I'll move the 5. 20 minus 5 e to the power of x plus 1 equal 15. And now you can take the len for both sides. So x plus 1 len e equal len 15. Well, we know that len e is 1. So x plus 1 equal len 15. And x will be equal to len 15 minus 1. So your solution is len 15 minus 1. That's your solution. And remember, it's not len 14, because negative 1 is basically this, len 15 minus 1, okay? So when you put it in the calculator, make sure to close the brackets. And then you can find the answer and round it to nearest two decimal places or one decimal place. And that's all. So see you next time. Bye.